Hello friends, welcome to Electronic Circuit Hub. So today we are going to design the buck converter for given requirement. So let us say if the input is 48 volt, output is 12 volt and the load current requirement is 3 ampere and let us say the switching frequency is 50 kilohertz and the inductance value for the buck converter is 500 microhenry and the capacitance value is 470 microhenry and the buck converter has to work on in the CCM mode, continuous conduction mode. So mode of operation for buck converter is CCM, that is continuous conduction mode. So we have to calculate today is calculate the duty cycle. What is the duty cycle for this requirement? And calculate the peak to peak inductor ripple current, that is delta IL. Okay, we're going to also calculate the output ripple voltage delta V naught. You can join our hardware design online course starting from tomorrow. The details are given here. Let us first calculate the duty cycle. So in the buck converter, the duty cycle D equal to V out divided by V in, and V out, the value of V out is 12 volt, and divide by 48. 48 is the input. So 12 volt divided by 48 into 100. So if you calculate this, you're gonna get 25%. So the duty cycle here is for this requirement, the duty cycle is going to be 0.25 25%. So we calculated the first question, calculate the duty cycle. So the duty cycle is 25%. Now let us calculate the second question regarding to calculate the peak to peak inductor ripple current. Okay, how you gonna calculate the peak to peak inductor ripple current is, so the formula for inductance calculation in the buck converter is L equals to V naught multiplied by 1 minus T divide by delta IL into Fs, and I want to calculate now here the value of delta IL. Okay, the value of delta IL, this I want to calculate the value of delta IL. So delta IL is going to be V naught into 1 minus D, V naught into 1 minus D divided by L into Fs. And if you plug in the values now, what is V naught? 12 volt multiplied by 1 minus D. 1 minus 0.25 is the duty. Divide by L, the value of inductance is 500 microhenry. So 500 into 10 to the power 6 multiply by 50 into 10 to the power 3. The switching frequency we have here is 50 kilohertz. So now 10 to the power minus 6 and 10 to the power plus 3, you can cut it and you're gonna get here minus 3. That means your 10 to the power minus 3 is still left. Now you have 2 0 here, 1 0 here. So you can cancel out total 10 to the power minus 6. So what is remaining now? 12 multiplied by 0.75. 12 multiplied by 0.75 divided by 5 5 is a 25. 5 5 is a 25. And then 5 25 3s are 75 and I take it out the 100 down. So 12 into 3 divide by 100, it is going to be 12 into 3 is 36, 36 and divide by 100, you're gonna get 3.36 ampere. So what is the peak to peak? Peak to peak inductor ripple current is 0.36 ampere, right? So delta IL, delta IL is the peak to peak inductor ripple current and which is 0.36 ampere. And if you now calculate the percentage of what is your peak to peak inductor ripple current percentage, so 0.36 ampere divided by 3 ampere, you're gonna get 12%. That means your load current is 3 ampere and you are getting 0.36 as peak to peak inductor ripple current. That means your ripple current of peak to peak inductor ripple current is 12%, and which means that your buck converter is operating in the continuous conduction mode. The mode of operation of your buck converter is CCM. Now let us calculate the third question, and in the third question, calculate the buck converter output voltage ripple. And how you gonna calculate the output voltage ripple, which is given by delta V naught. And you know that the capacitance value C equal to delta IL, the ripple current, inductor ripple current, divide by 8 times of Fs times of delta V naught, and I want to calculate the value of delta V naught, that is the output voltage ripple. So how I'm gonna get this? The output voltage ripple delta V naught is going to be delta IL divided by 8 into Fs into C. And now if you plug in all the values, all the known values here, so 0.36 amp divided by 8 into 50 into 10 to the power 3 is the switching frequency. And we have already got the in the question it is given the is 470 microfarad. So 470 into 10 to the power minus 6, and if you solve this you gonna get 2 millivolt. Okay, so the practically 2 millivolt is very seems, if you think of measuring 2 millivolt as a ripple, it very practically it impossible to measure that, because it's kind of noise. Even the 2 millivolt, even if you don't connect your DSO across the output voltage or across the capacitor, even you will see the ripple of 2 millivolt. It's very less, but for this calculation, for the value we have got, the output voltage ripple is going to be 2 millivolt. So hope guys you have understood how you're gonna calculate the duty cycle, how you're gonna calculate peak to peak, peak to peak uh, inductor current, how you're gonna calculate the output voltage ripple. And if you know, you can also calculate, if you know delta V naught, if you assume the delta V naught of your converter by using this C equals to this expression, you can also calculate the output capacitance value. And by knowing, by assuming peak to peak inductor ripple current, you gonna calculate the L value. So if you assume your peak to peak inductor current value, you're gonna calculate the L value. And output ripple voltage, if you assume, you're gonna calculate the C value. So hope guys you have understood how you're gonna design the buck converter, how you're gonna calculate the value of L, inductor value, inductance value, the peak to peak inductor ripple current, the capacitance value, and the output voltage ripple, and also the duty cycle. If you have any further question on this topic, feel free to ask me in comment section. Thanks for watching this video.